According to the Intergovernmental Panel on Climate Change, refrigeration contributes approximately 7% to greenhouse gas emission every year. This is solely due to the use of hydrofluorocarbon in the refrigeration, which are 1,000 times more potent than the carbon dioxide in terms of their impact on the environment. What if we could reduce the environmental impact caused by refrigeration? Right now, many scientists are working on a new method of refrigeration in which we will not have to use any kind of gas. This method is called ionocaloric cooling. But let's see how refrigeration started. In ancient times, people used caves and underground tunnels to keep food fresh for longer. This happened to keep the food below the temperature of the environment. Today, we use refrigeration techniques that have their beginning in the 1748 when William Connell demonstrated the principle of artificial refrigeration for the first time. He used ethyl in a vacuum condition, evaporated it and then condensated it, which produced the cooling effect. In 1805, Oliver Evans cooled the air with the help of a vapor compression cycle. However, there were still many limitations in the refrigeration system. In 1851, James Harrison made a refrigerator that was used to keep beer cool and for which he obtained a patent. Later in the 20th century, a new refrigerant CFC was discovered that made refrigeration even more efficient. However, due to the negative impact of CFC on the environment, it was later completely banned. Before we dive deep into the ionocaloric cooling, let's first understand how the current refrigeration system works. Currently, the vapor compression cycle is used for refrigeration, which involves using a gas refrigerant that absorbs heat from one place and releases it elsewhere. This cycle has four components: the evaporator, compressor, condenser, and expansion valve. The evaporator is the first component of the system and helps to form the refrigerant into vapor by absorbing heat. This vapor has a low pressure and temperature. Next, the compressor compresses the vapor, which increases its pressure and temperature. The refrigerant is then converted into a high pressure liquid in the condenser, where it releases heat. The expansion valve reduces the pressure of the refrigerant, which then cools and provides a cooling effect. This cycle continues to run continuously, providing us the desired cooling effect. However, since the discovery of the refrigeration system, it has been putting a negative impact on the environment. Initially, we used CFC gas, which was depleting the ozone layer. Later, we banned it and started using HCF, but it still has a negative impact on the environment. To address this issue, scientists have developed a new refrigeration system called ionocaloric cooling, which aims to completely eliminate the use of refrigerants. This technology has the potential to significantly reduce the environmental impact of a refrigeration system. When ice melts, it absorbs the surrounding heat and turns into liquid water. Similarly, when liquid water releases its heat, it turns into solid ice. This is the basic principle of ionocaloric cooling. Ionocaloric cooling uses a solid material that contains many ions. This solid material is placed between two systems, System 1 which has a higher temperature and System 2 which has a lower temperature. When we apply electricity to the solid material, the heat present in the solid material starts moving from the hot system to the cold system, absorbing heat from the hot system and releasing it to the cold system. Gradually, this process cools down the hot system. Scientists have developed a solid material with the help of iodine, sodium, and ethylene carbonate, which has been tested and found that it requires less than 1 volt of electricity to lower 25 degrees Celsius of temperature. This is much more energy efficient than the currently used refrigeration system. Support our mission of making scientific knowledge accessible to everyone by sharing it, liking, and subscribing to our channel. Don't forget to hit the bell icon. So see you in the next video. Bye bye.